Okay, so let's discuss a question from thermodynamics. It's a psychometry question from psychometry. So relative humidity is given as 60%, and we are asked to calculate the specific humidity. So relative humidity is nothing but the amount of the vapor pressure by in a mixture. Relative humidity at a point is the vapor pressure by the maximum vapor pressure that can happen at that temperature. The maximum vapor pressure which the air can hold at that temperature, that is nothing but Psat. So that is again obtained from tables. At 30 degrees Psat is given as 4.241. So 4.241 into relative into zero point 0.6, so that comes out to be 2.5. So let's write down clearly. So PV is zero point 0.6 into 4.241, so that becomes 2.546 kPa. So this is your uh, vapor pressure. Okay, now what is asked is specific humidity. Now specific humidity is mass of vapor by mass of air. Okay, so mass of vapor by mass of air is your specific humidity per kg of dry air. Mass of vapor, again we assume from the ideal gas, we apply that, we assume that both the vapor and the air behaves as ideal gas. So P, pressure of vapor by volume by R of vapor by temperature. V and T are same in a mixture. Similarly for air, pressure of air, volume, and R of air by temperature. So when we cancel T and V, we get R of A by R of water into PV by PA. Now this ratio, again these are nothing but universal gas constant. So then when you take gas constant and when you apply their values, like Ra will be R by M, M will be molecular weight, R by, I mean these are R of universal or molecular weight of air, and this will be R of universal by molecular weight of water, by molecular weight of water. So ultimately comes out molecular weight of water by molecular weight of air, and that is nothing but 18 by 28 roughly into PV by PA. So this value basically I'm deriving even though there is not a need. So molecular weight is 18 and for air it is 28.9. So this value comes out to be 0.622 PV by PA. So remember that this is the derivation of specific humidity. Though it is defined in terms of mass of vapor by mass of air, but when you convert, assume that both are ideal gas and convert, we get expression like this. So now we have to just substitute 0.622 pressure of, that's why we got the vapor pressure there that time. So 2.5466 by pressure of air, which is 1 atmosphere. Okay, the pressure of air we need to get. Okay, the pressure of air, let's see what is the pressure of air. Pressure of air is basically given as 1 atmosphere. Okay, so 1 atmosphere, water plus air, yeah, it's basically 1 atmosphere is the total pressure, but 1 atmosphere you have to subtract that 2.544. so let's do that. Okay, so this is PA, which is nothing but total pressure minus the vapor pressure. Total pressure is 1 atmosphere, which is 101 kPa, minus 2.5466. So this comes out to be, so let's substitute it here, 101 minus 2.5466. okay, so total pressure, here you have to use air pressure. So this value, what we get when we solve this value, we get about 0.016 Okay, kg of water by kg of dry air, because remember the definition, so you have to go by the definition. Okay, for the units, it's a unitless quantity, so 0.016 is the answer. Thank you.